All right, welcome back everybody. Today we're going to continue our look at conditional statements, conditional logic, by diving into Boolean logic more specifically, and we're going to use that as a way to make our programs a little bit simpler. So first things first, why are we talking about Boolean logic today? Well, because we want to write nicer code, more readable code, easier to understand code. Now, when it comes to conditionals, I really don't need anything beyond the simple if statement. Programs can get pretty big and bad and ugly if that's all we use. When it comes down to it, anything we can do with an if-else, if, even more complicated stuff like switch statements can be done with an if statement. The program doesn't run any faster with those more complicated setups. It just looks nicer, just makes our code more readable. It makes it look prettier. Same idea with Boolean logic. Let's take a look here. I've got some ugly code I'm going to say. And what is this program doing? Well, it's deciding if the age is less than or equal to 18 or by default greater than 18. And then if it is less than or equal to 18, so for a kid in other words, it's going to check and see if the day is Saturday. If so, it'll print out $5 for a ticket or something like that. Next, it'll check and see if the day is Sunday. If so, it'll print out $5. Otherwise, the ticket is $10. And I suppose if we're greater than 18, it's $10 no matter what. We've got some repeated stuff, and the thing that should kind of tip us off here is there's two different instances where it's printing 5 and printing 10. So what I'd like to be able to do is break this down into a single conditional where there's only two outcomes, print 5 or print 10. And we'll do that utilizing some Boolean logic. Now, reminder, what is a Boolean? A Boolean is any condition or variable that can be evaluated to true or false. So in the examples we have here, we have a variable stop, which we're assigning the Boolean value false. Or go, which we're assigning to true. Or a condition, or in other words, an expression, x gets or equals 10, or z is less than or equal to 20. Those are both expressions or conditions we get assigned to true or false based on the values of x and z. Booleans are great because they allow us to make decisions. Now, what we're going to get into now are something called compound Boolean expressions. So in other words, combining Boolean expressions together, and we'll do that using our three basic logical operators. The AND operator, the OR operator, and the NOT operator. These will be three ways that we can take individual Boolean expressions and put them together into something more complicated. So let's take a look at how each of those operators work individually. The first one we'll talk about is the AND, so one condition and another one happening. We'll type that into our program as ampersand, ampersand. And it will evaluate to true when all the conditions have to be true. One condition and the other one has to be true. So for example, we could say if C is equal to true and S is equal to true. Now for this, I actually don't need the equal equals true on either side of these. If C and S are Boolean variables, we can just say if C and S. We'll put that in there to help us think about this one. This code will run when both C and S is true. Another way to think about this would be with a truth table where I have my variables C and S, and they can both be true or false. So here's all my different combinations of C and S true and false. The only way for C and S with that compound operator and to be true is if they're both true. If one of them is false or the other's false or they're both false, this expression will evaluate to false. All right, we can also talk about one condition or the other one being true. That's our OR operator. That is the double whatever these signs are called. I have no idea. It's above the enter key, below the backspace key when you hit the shift. Whatever those vertical lines are called. And these will be true when either condition is true. So again, if we evaluate if C equals true or S equals true, this code will run if one or the other is true. So again, to our truth table, if they're both true, C or S will be true. If just C is true, C or S will be true. If just S is true, C or S will be true. The only way to get this condition false is if both our conditions involved are false. And the last logical operator we'll talk about will be the not operator. Okay, we'll write that in our code with an exclamation point, and this is going to be true if the condition is false. So if I say if not C equals true, this code will run if C is equal to false. Okay, so this kind of does the opposite of the condition. If C is true, not C would be false. If C is false, not C would be true. And the reason we'll use this is a lot of times it's easier to think about a situation in terms of it not happening than happening. Okay, we'll show you some examples in the homework where the not makes more sense and makes things simpler than the kind of condition being true. All right, and again, the reason we're talking about Boolean logic is we want to make our programs look nicer. Okay, I'd say this is a lot prettier code here than what we started the lesson talking about. Okay, that's kind of a mess of nested conditionals. Okay, between the two of them, neither are going to run faster than the other. The computer still has to do the same number of checks and work. But I'd say this is a lot easier to write and a lot easier to read. Okay, looking at this code, I can tell right off the bat what we're trying to do. We're trying to make it a $5 ticket or discount or whatever. Okay, if the age is less than 18 and the day is Saturday or Sunday. Okay, or else we'll make it 10 by default. Again, I'd say it's a lot easier to tell what's happening than when I look at this mess of conditionals right here. Now, as I start combining more and more Boolean operators along with other logical operators, we do need to think about precedence as far as when Java runs which command as we go through these. Okay, so as far as order of operations go, starting off with, we're going to be doing the math, okay, the parentheses, addition, subtraction, multiplication, division. Then we get into the comparisons, greater than, less than, is it equal to, is it not equal to. Okay, and then comes our logical operators, okay, the and followed by the or. So if it comes down to it, we'll evaluate the and first, then the or second, and then we'll get into the actual assignments. So as I look back at that previous problem we just looked at, the way Java is going to read through this is it's going to check the greater than or less than first. So basically it'll evaluate this chunk first. It'll then do the and, thinking about this is a condition and this whole thing is a condition. Then it'll get within the parentheses, okay, check the equal sign, then do the or. Okay, so there is some order of operation to think about as we do more and more complicated Boolean expressions. All right, so let's run through some code with compound Boolean expressions and figure out what they're going to evaluate to, figure out what they're going to output. So what's the output of the code segment? We have num gets 5, Boolean A gets true, Boolean B gets false, and then we have this conditional that's going to display either true or false depending on this condition right here. Okay, so we've got an and operator. So for this expression to be true, both the left side has to be true and the right side has to be true. Well, let's see here. Left side, num greater than or equal to 3. Num is 5, so that would be true. Okay, right side, we've got an or condition. So the entire right side will be true if either A or B is true. And when you see just, again, an individual Boolean in here, this A by itself means the same thing as A equals true. Same thing here, B equals true. Now, since A is true and B is false, the entire thing will evaluate to true. Okay, so we have true and true, therefore this entire condition is true. So this should output a true when the code runs. All right, let's take another look at another example. And this one's kind of reversed. We've got ands within the parentheses, and or is kind of the larger operator combining two different Boolean expressions. So we've got the same, num gets 5, A is true, B is false once again. And for this one, this entire expression will be true if the left side of the or the right side is true. Okay, so let's take a look at inside each of the parentheses first. So I have an and, meaning that both sides have to be true for the entire expression to be true. Now num's not equal to 1, which is true. And B, so in other words, B equals true. Now B is false, so that part is false. And since we're talking and, that means that this entire left side of the expression is false. Okay, now the conditional overall could still be true if the right side is true, so let's take a look at that. Again, we've got an and within the parentheses, so both sides of that and have to be true. Num is greater than 2, num is 5, so that is true. A is true, meaning that this whole thing here is true. And again, since we're dealing with an or, since one side of it is true, that makes the entire thing true. So once again, we'll get true output to our terminal, okay, from this program here. Now, as you can see from the last example, things can get a little tricky when we start combining more and more Boolean operators together. Okay, you can end up with kind of something that's sort of a mess to evaluate. Okay, that's why we have some shortcuts, some rules, such as the two I'm showing you here, DeMorgan's law. And basically what they are a way to rewrite different Boolean expressions. Okay, maybe it's easier to think about it or program it in one version or the other. Now, with DeMorgan's law is basically a way to kind of distribute the nots. We could say that not C or S is the same thing as not C and not S. And then flipping that around, not C and S is the same thing as not C or not S. Let's take a look at why those are true. So again, we can kind of think of DeMorgan's laws as taking a not operator and distributing it to all three parts. Okay, so we have a not C, not S, and then the or kind of changes to an and. Now I think common sense wise this makes sense. If I don't have C or S, that means I don't have C and S. C and S both have to be false. Now, as far as proving why this is true, what we could do is use a truth table again. So I've got my different combinations of C and S's here, whether they're true or false. Okay, now C or S will be true in all cases except for when they're both false. Now, not C or S will be the opposite of that. It'll be false when C or S is true, and true when C or S is false. Okay, and what I want to do to make kind of the proof of this law here is I want to show that the not in parentheses C or S has the same truth values of not C and not S. Okay, so we'll kind of go back to here. Not C and not S will be false when they're both true. Okay, because these would both have to be false. It'll be false when either one of them is true, because again, they both have to be false. And not C and not S will be true when both are false. And again, the reason this law works here is because these two columns of the truth table match up as far as truth values. Okay, so that's why that part of DeMorgan's law works. Let's go ahead and prove the second half of that for you quick then. So why is not C and S true when either C is false or S is false? Well, for this to be true, either one of these has to be false. Okay, so again, kind of common sense wise, it makes sense. But proving that with the truth table, C and S is true when both C and S are true. Otherwise, it's false. And if I do the not, the opposite of that, that'll be a false, true, true, true. And then not C or not S will be true when either one of these two are false, meaning that when they're both true, it'll be false. But when I have either C or S false or both of them false, this would be true. Okay, again, the reason this law works is because the two columns of the truth table match up and have the same values. And again, what we have is you can kind of think of this as distributing the not to all three parts here. All right, so let's go ahead and practice using DeMorgan's law to simplify a Boolean expression. And I guarantee you're going to see a problem on the AP exam where they give you a Boolean expression like this, and they'll say, what is it equivalent to? In other words, simplify it down. So what I can do here is I can basically think about distributing my not to the three different parts here. Okay, so I'm going to put an equal sign. Even though we're not technically doing math, it kind of works the same way. So first thing we'd have is a not x is greater than 5. We'll rewrite that in a second. The and will change into an or. And then when I have a not, kind of a double not here, it's kind of like a negative times a negative. That'll turn into a positive. So what I'll have here is a G or not Q. All right, now I don't need to worry about distributing this not into here. By canceling out the not here, we'll say it's good. Okay, so what does not x greater than 5 mean? Okay, well that just means that we can flip that around. X is less than or equal to 5. Or I suppose we should lose that line below. We're not talking math class here. We're doing programming. We'll write it like that. So this will simplify down to x is less than or equal to 5, or we'll say in parentheses G or not Q. And then I guess the last thing we can do, since there's no order of precedence between these two ors, we could just say x not or less than or equal to 5, or G, or not Q. Okay, and get rid of all those parentheses. Okay, why would we want to rewrite something like this? Okay, maybe it is easier to think about in one version or the other. Okay, maybe it's going to be easier to make it match up the variables we have in one version or the other. And like I said, also to get problems right on the AP exam, there will be questions where they ask, usually multiple choice, which expression is this one equal to? Well, you'd have to pick between the different possibilities. All right, we have one more Boolean logic topic we're going to talk about, and this is something that's not common in every single programming language, but Java does use it, the idea of short circuit evaluation. Basically, Java evaluates Boolean expressions from left to right and stops the evaluation process once a condition is found that can complete the expression. Okay, so what does that mean? Here's an example. So we have an AND operator here. Now for this conditional to be true, both the left side and the right side have to be true. Now if we get to the point where the left side is false, we automatically know that the whole thing is false because it's AND. All right, so Java doesn't need to evaluate further, therefore it'll stop once it gets to the part where we know what the answer is going to be. Okay, this would work the same way with an OR operator. If the first expression is true, it doesn't matter if the second part of it's true because the OR only needs one of them. In that case, it would stop evaluating also. Okay, why is this handy? Well, in the case of a program like this, if we set num equal to 0, I can't do modular arithmetic with zeros. I can't divide by zeros. So this right half of the Boolean expression would actually crash my program. Okay, we would throw an exception, which is why a lot of times what we'll do is we'll check and see if it's 0 first, and if this is true, if it's not 0, then and we'll go over here and then run our code. Okay, but if we get the 0 right off the bat, Java's going to cut it short, and we don't need to worry about this piece crashing it. It's just going to say the whole thing's false and move on. Okay, so the big reason we want short circuit expression is going to help us avoid errors in the second half of our Boolean logic. All right, so there's our in-depth look at Boolean logic. Start working on programs, start cranking out some code, go through the homework, go through the coding exercises. We'll get into the lab tomorrow, and like usual, if you end up stuck, let us know. We're here to help you out.